We're going to look at solutions of quadratic equations, and I'm using this textbook, which is on page 195, the student book endorsed for Edexcel, International GCSEs Maths by Chris Pierce. It's a Collins book, so you can access this in any of the bookshops. I got mine from W.H. Smith. So we're going to look at quadratic equations, solutions of equations, and the book I'm using is the student book endorsed for Edexcel, IGCSE Maths by Chris Pierce. So let's very quickly start looking at the topic. Solutions of equations are in various forms. I'm going to first of all look at the higher tier, more complex equations, and I'm sure by now most of you guys students on this program will have covered other topics that we talked about. So we're going to look at the solutions of more complex equations. What constitutes a complex equation? We are going to look at a scenario such as this one. Very quickly, I'll take, for example, you're given a question, x plus 1 over 3 minus x minus 3 over 2 equals x minus 4. So these are more complex equations. I would simply say more complex equations. And if you recall, or if you haven't looked at the idea or rationale behind equations, we're actually looking at, if you see the equals there, let's think of that, the seesaw. In other words, both sides, this, the left and the right, they must balance. They must balance. They must balance. This is the idea behind the equations. When you hear the word equation, which means the left and the right are equal. They are all balanced. So whatever you do on the right must be done on the left. So the best way now to do this equation, to solve this equation, is an example. So you want to make sure that this side is written as a single fraction. Single fraction. The normal way you add fractions is where you're going to add. So you're going to find the common denominator on the right. So you get, the easiest thing is to do 3 times 2. So these 2 here comes in the denominator. You want to get a factor here in which 3 can go into exactly. So you do 3 into 3 times 2, which is 6 here. It is 2 times. And 2 times the factor on top. The same thing you do there. 2 divided into this product is 3 times. Then 3 times the upper or the numerator, which is that. Because the idea behind this, want to convert this into a single fraction. You still maintain this side, x minus 4. Once you get to that stage, I'll start writing a bit smaller. We proceed. We proceed. You have to multiply through the brackets, or you can keep it there like that for simplicity. I'll show you another way. Just do 2x plus 1, I beg your pardon, let me quickly go to the next page. My handwriting is quite big there. So we were at 2x plus 1 minus 3 x minus 3 is equal to x minus 4, and there was 3 times 2. I'll quickly cross multiply. Cross multiplies. So very quickly this becomes 2x plus 1 minus 3 x minus 3 is equal to, this one crosses over to 6x minus 4, because this one is equal to 6 on its own. This one, this, when you multiply this by itself, becomes 6, but when you cross multiply, because of the other side. In the simple way, if you got confused, it's simply multiply throughout by 6 to get rid of that. So I'll just put that in blue. How I got to this stage, all I did was, because this is 6, so it's like that. Because that is 6, I'm going to write it blue. So because this number is 6 there, so the equation was like that. Watch this. Okay. Over, because that one is 6, that one. So that one is equal to x minus 4. So now to get rid of the 6, all I do is I multiply on this side by 6. I'll also do the same, multiply this by 6. So that cancels, that cancels. So what I have now is this expression here. What I have now is that expression over there. That's how we got to that stage. Okay? Once you get to that stage, once you get to that stage, let me get rid of that very quickly. You have, once you get to that stage, what you have there, you have equation. Now you need to expand through the brackets. You have to expand through the brackets. So it is 2x plus 2 minus 3x plus 9 equals 6x minus 24. Then of course you simplify the normal way. On getting the like terms together, all these, you see, all these terms in x's must come together. Put them on one side. Now there's a simple thing that I tell students. If you do get confused, simply do, if you're going to move this 6 over this side. The moment you do that, what happens to it? It's called minus 6x, because it has crossed the equal sign. Jumping over the side becomes minus. So what you have now is 2x plus, I'll just put minus 3x there, minus x. You've got all these like terms on one side. Can you see that? Can you see that? Yes, you can. Yes, you can. So now we compute this very quickly. That is minus 9 minus 9 plus 2. That is going to be minus 7x. Okay? Minus 7x. You just compute these numbers on their own. So you put it on their side. The same thing you do now. All these numbers like this plus 2 must now cross over to the other side. The same way it becomes minus 24 minus 2. 9 must cross over to the other side. It becomes a different number in terms of sign. So if on this side you have now, this is on your calculation pad, you have minus 24, and you have minus 2, and you have minus 9. So what you're going to end up with that is going to be minus 35. So you're going to have total sum of these will be minus 35. So now once you do that, writing this equation in full will simply be like this. On the left, you've got minus 7x is equal to minus 35. So to convert this into a positive, you multiply on both sides by, divide both sides by minus 1. That's a common factor there. Divide both sides by minus 1. So you get 7x is equal to 35. Okay. So once you do that, pretty clear. Divide both sides by 7. Why? Because you want to get rid of 7. Because you want x without a coefficient. Without a coefficient. So when you do that, you simply get x is equal to 35 divided by 7, which is now 5. So you have solved that system of simultaneous equations. Oh, you have solved a more complex equation in that sense. So this is one of the methods that you can use, and it's very important to note this point. When I was calculating these parts, these parts where you move the number over there, changes sign, makes it easier for you to see these things quickly. Similarly, when you move a number from here to there, it also changes signs, becomes minus 2. The same thing with 9 becomes minus 9. 24 is there already, minus 24. Then you add them up easily. And the same things we did with these other terms in x. So you add them up, they give you that number. And over there they give you that number. And then what follows you now is to make sure you just see them in that order. And then you divide by 1 on both sides, see them in that order. And finally, divide both sides by 7 because you want to get rid of 7 and remain with the x only as a coefficient, which is x without a coefficient of 7. So there you have x is equal to 5 over 7, and you have solved the equation. This is one method that you can use. That's a very important method you can use, because you know that you're following step by steps and you're going to get the answers right. Now I'll just bring myself up a little bit there. So it's what's this now? Okay. Okay, that is one of the ways we are going to solve this kind of equation. Now I'm going to give you a second method, and you can go through this by yourselves in the textbook which I've recommended. And if you find any difficulties, just drop me a line and we'll talk about this. Okay, let's look at the second method. And it depends on which method is easier for you, unless the examiners tell you to use one method or another. You could use either of the methods. Look, read the instructions. The second method, we are going to call it method 2. Method number 2 we are going to hunt for the lowest common multiple. You look at the equation, the question, which is x plus 1 over 3 minus x minus 3 over 2 is equal to x minus 4. Now, what is the lowest common multiple for these two? Okay, it's 6. So if you do that, you multiply through, or you multiply this through by 6. So you're going to say each term now is multiplied by 6, and the other side as well. So we say 6 times this whole thing over 3 minus 6 times this whole thing, and 3 over 2 is equal to 6 times this side as well. Can you see that? And this becomes pretty easy for you. So what you do, you calculate. That cancels. That's 2 there. That cancels. That is 3 there. So what you have here is now 2x plus 1 minus, I beg your pardon, minus, so just gonna write that again. What you're gonna have now is 2, in fact you can straight divide, multiply through in the brackets, 2x plus 2 minus, yeah, that's 3 minus 3x minus 9 minus 9, that's a minus, that's the plus 9 is equal to 6x plus 4. Was it a plus 4 minus 4? It was a minus. What is minus 4 here? Minus 4. 6x minus 4. Can you see that? It takes you back to this stage. It takes you back to this stage here. Can you see that one? Do you remember that? Yes. So once you get to that stage, everything is straightforward. So you rearrange the sides. Once you rearrange the sides, what you're going to get is the same thing. It will be 7x over that side will be equal to 35, and then you just straightforward do the same things as you did before, and you're going to get the same answer as x is equal to 5. This is method 2, and look, method 2 look pretty straightforward and quicker than the first one. So it depends on what the question is asking of you to do. Very much important to take note is to read the question during examinations, which method they're asking you to use. If you see anything saying use the lowest common multiple method or whatever it is, go for it. But otherwise, you can use any of these methods. Okay? So, as I just bring up myself there, okay. I think at this stage we can end here, and let's go through some examples and questions in the next phase. So as we close this part, well, I just introduced two methods in more complex equations. We're going to go through some of the questions that you can solve. If you're using the textbook which I've recommended, I think try to do exercise 13E, page 205. Try, as my students of mathematics in WMOC, use this book, go to page 209, page 205, sorry, and work out all the exercises there and drop me a line and let me see how you're doing. Thank you very much. Signing off, this is Dr. John Lukomona for mathematics, but still present with you online. Ciao.